All right, so today we're going to practice finding the area of triangles. Now, in geometry, you probably did this a lot, and usually those triangles are right triangles, and you did 1/2 base times height. So we're still going to do that, but it takes a little more effort to find the base and height when it's not a right triangle. So, case one, if you're given two sides and the included angle, all right? So what does that mean? Well, that means like you're given side B and side C, and the included angle has to be the angle in between B and C. So like the included, if you're given sides A and B, then the included angle would be C. And if you were given angle B, that would be the included angle for A and C. All right, so included angle means in between those two sides. All right, so notice this formula here. So let's just look at this one for a second. All right, S is equal to 1/2 BC times the sine of A, where S represents the area. So we're going to just use this one. And they all work the same way. It just depends on what angle you're using. All right, so the reason why this formula works is it's just 1/2 base times height. And you sort of see that there with the 1/2. But where's the height part? Well, if I were to draw this height, now remember, height is another word for that is altitude. By definition, it's always the length of or the distance from a point on a triangle, all right, perpendicular to the opposite side. So real quick, if h was the height, then that pink side would be the base. Or if we made this the height, then this would have to be the base, all right? Or if we made this the height, then this side would have to be the base. So you can use any base and height pair, but usually there's going to be one pair that's easier to find than the others. All right, so let's hypothetically say that we were given angle A and also the two sides next to it. All right, so then we use the purple or pink, call that. So now the height, oops, it's all good, Danny. All right, so the height would be, to find it, you would set up SOHCAHTOA. You'd say the sine of A is equal to H over B, because we have this like right triangle here. And the opposite leg would be H, and the hypotenuse would be B. So that means that if we solved for the height, that would be cross multiply, right? We'd get H is equal to B times the sine of A. All right, so now if we look at this formula here, all right, we got B times the sine of A in there. So that part's the height. And then we also have C, which would be the base if we're using H there as the height. So we're really doing, and then you got the 1/2 there. So we're really doing 1/2 base times height. So instead of memorizing those formulas in case one, I would just, if you're given like that I have circled in green, two sides and an angle, then find the height across from the angle that you're given, and then multiply by the base and divide by 2. So let's try it in example 1. All right, and then we'll talk about Herron's formula when it comes up, because we're going to use that when we're given 3 sides. So we'll come back to that. All right, so let's draw the picture out here. So I'm going to draw it out. A little hard to do here, but you can do this along with me. All right, so I'm going to make a 120-degree angle. So I'm not drawing this perfectly to scale, but sort of to scale. All right, so I'll make this 120. All right, so then this would be angle C. And then who cares? I'll make this angle A and this angle B. It doesn't matter which one's which at that point. Now, side B would be 12. So that's across from angle B. And side A would be 10. Oops. I don't like how I drew that. Let's make it there. Nice. All right, now this is an interesting case here because it's an obtuse triangle. And it's interesting because the height is outside of the triangle. So remember, our definition for height, so we're going to use 12 as the base, right? So 12 is going to be our base. The height is the distance from the vertex opposite the base straight down to the height. Now, if we were going to go perpendicular to this height, we're going to have to extend this side out. All right, so this right here represents our height. It's the height of the triangle. So if you have an obtuse triangle and you got to find the height, you just take one of the vertices and you draw it perpendicular to the other side. And like I have with that dotted yellow line, sometimes it's going to come out to be, it's going to be outside the triangle. All right, so if we were doing the area, we'll call it S. It's going to be 1/2 times the base, which is 12, and then times the height, which we don't know yet. So to find the height, we're going to use this right triangle here in yellow. So I need to know that this angle here is 60. And now we could do SOHCAHTOA. We could say the sine of 60 is equal to h over 10, which means if we cross multiply, the height is going to be 10 times the sine of 60. All right, so now we can type that in our calculator and get the height. Now, if you remember from your chart, like sine of 60 is equal to root 3 over 2. Oops, someone's trying to join. I gotta let them in. To do this without a calculator, you know it's going to be 10 times root 3 over 2. I mean, or you could just use a calculator. All right, and then you get the height is 5 root 3. Because that's 10 root 3 divided by 2 would be 5 root 3. So you just plug that in right there, and we have our area. All right, so now I'll do the calculator part. All right, and remember, to find the height, we just did the sine of 60 was equal to h over 10. And then if we solve that by multiplying both sides by 10, we get the height is 5 root 3, which if you want to put this as a decimal, you get 8.66, whatever. So the area is going to be 1/2 or 0.5 times the base, which was 12, times the height, which was that. And we get that the area would be around 51.96 square units. So if you want to just round that up to 52.0, all right, you can do that. Now, that'd be the area. And it's always in square units. So make sure you always put it in square units because area and length are different, right? Area is how many squares you could fit in something. Length is like length. Now, you might be thinking, well, that's different from this formula here. And you're right, it is a little different from the formula because the formula says if we were using the top one, because we're given angle C, it would be 1/2. So control division, 1/2 times A, which we said was 10, right, times B, which was 12, right, times the sine of C, which wasn't 60, C was 120. And now if we compute that, we get 30 root 3, which is also equal to 51.96. Now, the only difference with this and what we did was that I used the sine of 60 instead of the sine of 120. But we know from our studies of trig that the sine of 60 and the sine of 120 are equal to each other because they're both in quadrant 1, or one's in quadrant 1, one's in quadrant 2, but they're both in positive sign quadrants, and they both have the same reference angle. So if you want to just use the formula and plug and chug, all right, you would do it this way, and you get the same answer. It's totally fine. Me, I'm not a memorizing formula type of guy. I like to really think about what I'm doing. And the way I know how to find the area of a triangle is to do base times height. And so that's how it would look. All right. So that's all you got to do for number 1. All right. Now for number 2, to try to like not bore you guys too much, I'll just show you the plug and chug way of doing it. So in number 2, let's draw the triangle out. All right, now we're given a triangle with a 16-degree angle. All right, so this would be 16.3 degrees. And that would be angle B. I'm sorry this takes forever. It's just really hard to draw. All right, and then I don't know what these rests are going to look like, so I'll just connect these dots here. All right, and I'll make this angle A. So this would be 76 38.3, and this angle C, so this would be 42.8. All right, so we're given, again, side, angle, side. We're given two sides and the included angle. So we can now just use this formula because we have angle B and we have A and C, the sides next to it. So now, I mean, if you wanted to, you could draw the height from A. If the formula confuses you, or if you want to do another way, you could find this height here by doing SOHCAHTOA with 16.3, H and 42.8, get the height, and then do base times height divided by 2. All right, but you get the same answer as if you just plug into the formula, 1/2 times the base. In this case, it would be side C, so 76.3 times A, which is 42.8 times the sine of angle B, which in this case was 16.3. And again, this, I'll put it in parentheses, like this part in its parentheses, and I'll highlight it. This represents the height. That's the base. We'll have base times height. Again, if you did SOHCAHTOA to find the height, that's what you would type in the calculator to get that. All right, so hit enter, and you get your area. So for number 2, the area is 458.27, so we're on up to 3. All right, square meters. And in the previous example, I wrote square units. That was silly. In the previous example, I should have wrote square centimeters because that's what the length was given as centimeters. All right. Any questions? Let me know. No questions? We'll keep moving. Now so I'm going to be referring to this formula. I'm not going to keep scrolling up, but I'm going to write this one down. But let's talk about it for a second. When we're given 3 sides, we're going to use what's called Herron's formula, which I know I recently said like 5 minutes ago, I'm not a plug and chug type of guy, but I have to be a hypocrite right now. When you're given 3 sides, I do just plug and chug into Herron's formula because it's super easy if you know all 3 sides. Because A, B, and C represent the sides. So an lowercase s stands for semi-perimeter. So semi is like half, like a semicircle is half a circle. Semi-perimeter is half the perimeter. So if you're given all 3 sides, the first thing you do is find the semi-perimeter. So add up the sides and then divide by 2. And once you have the semi-perimeter, you multiply that times the difference of the semi-perimeter and all 3 sides. You multiply all those 4 things together and then take the square root. And now I'll give you the area. Now, there is some sort of proof to it, but like it's really complicated. And I actually don't know the proof of it off the top of my head. So I feel like you don't really need to know where it comes from. If you're interested, I'll be happy to look at it with you, later. We can explore it more. But I mean, all you really need to know is just how to use this formula. You don't even need to memorize it because we're virtual. So you can just, write it in your notes and use that. And if we weren't virtual, I would just write it on the board or put it on the test. So I'm more worried about you using the formulas. So let's skip a little bit to 5 since I'm just talking about it. I know I'm skipping around, but let's do 5 because 5 gives you all 3 sides. So I'm going to do this all in the calculator because drawing a picture would just sort of be a waste of time. All right, so if I were to draw this picture here, I would just make a triangle and make one side 48, one side 75, one side 63. Now to find the area, we're going to do Herron's formula. All right, so first we got to find the semi-perimeter. So we're going to get that by adding up all the sides. So 48 plus 75 plus 63 and dividing by 2. So the perimeter would be like 186. So the half of the perimeter would be 93. All right, so to use Herron's formula, I'm going to hit the square root button. And then under the square root, I'm going to do the semi-perimeter times, and then parentheses, the semi-perimeter minus one side, A, and then the semi-perimeter minus another side, and then the semi-perimeter minus the third side. All right, so hit enter, and we get this cute simplified radical, which if I was like hiring a contractor to put pavers down in my backyard and the dimensions were a triangle, and he was like, all right, you got 270 root 31 square feet. I'd be like, dude, just tell me what it is in feet. All right. So a lot of times in the real world, like you're not going to get answers in simplified radicals. In math world, it's good to have exact answers, but we're talking about areas of actual things. We want to round to a decimal. So it would be, if I convert that to a decimal, we'd get 15.03. All right. So that's number 5. All right. If I asked you to show your work, I would just look for you to write this part down here. All right. So for 5, that's all I got to do. So for 6, we'll do the same thing. We'll take the semi-perimeter, so add up all the sides. Now, if you don't have a T-Inspire and your calculator is different than this, and you need help, just ask and stay later, and I'll explain how to do this on your calculator if you're getting different answers. So do this along with me. Make sure you're getting the same answers. All right, so first I'm going to find the semi-perimeter. So control division to get that fraction bar, right? 8.32 plus 6.23 plus 3.45. All right, and then divide by 2. And I guess the perimeter is 18 because the semi-perimeter is 9. All right, now we are going to take the semi-perimeter, multiply it by the semi-perimeter minus each side, and then take the square root of that. And so I do work a lot slower virtually because it's a lot more to manage. But for you guys, I think it's good because it allows you to kind of work along with me. So if I'm going too fast, just tell me. If I'm going too slow, then that means you're probably just sitting there and not doing anything. So, feel free to do this with me. All right, so now hit enter. Boom, there's the area. All right, now could you figure out what one of these angles are and then do the other method? Totally, you could do that. But if you're given all 3 sides, it's easiest just to do the Herron's formula. All right. So now let's go back and look at 3 and 4. And what do we do when we're not given one of these cases? So case 1 says you're given 2 sides and the included angle. Case 3 is when you're given 3 sides. Well, you might be given only 1 side and 2 angles. Well, in that case, you got to find the side. So let's do it here. So for 3, I'm going to have to draw the triangle. And my computer's dying. So give me 1 moment. I got to plug it in. Sorry, give you a head start on drawing the triangle. All right, so let's see. Just make it look like this. I don't really know exactly how it's going to look. I'll make this angle A 31 degrees, or make that angle C rather. I'll make this 57 degrees. Call that B. And then I guess this would have to be angle A then. So I'll make this 7.3. And you could have drawn it differently. It's fine. It's just make sure, angle C is 31, angle B is 57, and the side across from angle A is 7.3. All right, so now what do we do? Well, if we look here, if we think about like base and height, all right, we could find this height pretty easily by doing SOHCAHTOA, all right, and then we just need to find what this side is here. So let's find that third side. And if we do that, then we would have, if we figure out what this side here is, we'll call it X for a moment, then we have 2 sides and the included angle. And we could do the case 1 method, like 1/2 times X times 7.3 times sine of 57. So we have to figure out what that side is. So if you're not given 2 sides or 3 sides, then you're going to have to find a second side in order to do the area. All right, so first, let's figure out what angle A is, because we need that to figure out what side C is. All right, so let me call this side C. And to find angle A, it's pretty easy. We're just going to subtract those 2 angles from 180. So on my calculator, I'm doing 180 minus 31 minus 57, and this is 92. All right, so not drawn to scale. It's okay. All right, and now we could find side C by doing the law of sines. Sine of 92 over the side across from 92, which would be 7.3. All right, so good review of law of sines, equals the sine of 31 divided by the side across from 31. All right, so now I'm going to type that in my calculator and cross multiply. So I'm going to do 73 times the sine of 31, and then that's going to equal the sine of 92 times C. So then I'm just going to divide both sides by the sine of 92. So figure out what that is. Divide by the sine of 92. Hit Control Enter, so I get a nice length. And I get 37.6. So I'll just round to one decimal place there. So this will be 37.6. All right, now I have side angle side. So like I said earlier, you could then think about this and find the height by doing like the sine of 57 equals h over 73. All right, and then do 1/2 base times height. Or you could plug it right into that formula, which is kind of doing the same thing. Do 1/2, so 1/2 times 7.3 times 37. Wait a minute. Something isn't right here. How is that side 7.3? Oh, no one. Come on, guys. Can you tell me I made a mistake here? All right, so I put in 73, not 7.3. So luckily, that's an easy mistake to fix. You can move a decimal place over once because I multiplied by 10 too many. So it should be 3.7. So let's fix that. Now, I was about to say something, and I'm very distracted working at home, so I forgot. Also don't have great memory. So I was going to say, anytime, and I've said this before, anytime you find, oh man, what the heck? Anytime you find a side or an angle, do what I call a common sense check. So what that is like, look at 92. All right, the side across from 92 is 7.3, which means the side across from 31 should be less than that. It ended up being way more than it. So I should have noticed something was off. And I did later on when I finally did that. So anyway, back to the calculator. So easy fix, we're just going to change that to, so we're going to do 1/2 times 7.3 times 3.76 times the sine of 57. And then look what I'm doing here. All right, if you have side angle side, like this, side angle side, all you're going to do is 1/2 times the two sides times the sine of the angle in between. Right? And that's essentially like finding the height, then multiplying by the base and dividing by 2. All right, so then we hit enter and we get our area. Boom, 11.5. All right. Any questions? All right, so one more here. And so let's try to draw a picture. So I'll clear this out so I have room. Okay, so number 4. All right, I'm going to try to draw this to scale. What I mean by that is I know angle A is obtuse, so I'll make it look like an obtuse angle. All right, so this angle, we'll call this angle A because I made it look obtuse. This would be 110.4 degrees. All right, then this looks like 21 degrees, so we'll make this C equals 21.8 degrees. All right, and then this by default would have to be angle B. And this would be side C. We know that would be 240 inches. All right, so I'm given angle, side. So I'm not given side, or side, angle, side. So I'm going to have to find a second side. So to find the area, you need at least 2 sides. So to find the second side, they can either be this side here or this side here. It doesn't matter. either way, we're going to need to figure out what this angle B is. So let's just find angle B. Anytime you're given two angles in a triangle, just find the third angle. It's really easy and it'll probably save you more headaches than create extra work for you. All right, so we get 47.8. This angle here is 47.8. Now, the way I'm about to show you how to do it, it's not the only way to do it. You could do it different ways. But I'm going to just figure out what side CB is. So I'm going to do the law of sines. I'm going to do, oh man. I'm going to do the control division. My screen isn't big enough. All right, so I'm going to do the sine of 21.8 over 240 equals the sine of 110.4 divided by the side across from it. So we'll call that A. Now, I could have found side B. It doesn't matter. In order to find the area, you either need all three sides or you need side angle side. So here I have side angle, so I can find this side, right? Or here I have side angle, I can find this side. Doesn't matter. It's going to be the same area either way, right? So I'm just going to find that side by doing what's on the calculator. So cross multiply. So I'll multiply both sides by 240. So this would become 240 times that, and then multiply both sides by A, and then divide both sides by the sine of 21.8. And we get side A is 605, which if we do our common sense check, all right, that seems okay because it's across from the biggest angle. So it should be the biggest side. And it's not like crazy bigger than 240. It's 3 times bigger, which makes sense because, you know, this angle is much larger than 21 degrees. All right, so our common sense check worked out. All right, and then now, like I said, if you want to get real mathy with it and you want to like draw this height and find it by doing SOHCAHTOA with this purple right triangle or pink, whatever you want to call it. All right, you could do that, find the height, and do base times height divided by 2. All right, or the simpler method, if you know the formulas written on the top of these notes, would be to just do 1/2. So 1/2 times 240 times 605.7 times the sine of 47.8. All right, so again, that formula is just 1/2 times any two sides in a triangle times the sine of the angle between those two triangles. So those two sides. Since I did 240 and 605, the angle in between 240 and 605 is 47.8. Right, and we get our area is quite large, which makes sense because the sides are quite large. So our area is going to be that. All right, and that's very large. That seems really large. But I think it's, yeah, I'll add an extra 4. That's maybe 8, 4. What's going on? Why is my head 53? Oh, I added an extra 8. Okay. There you go. 53,000. That seems more reasonable. Okay. So, and that's how you find the area of a triangle. So let me end this video. Don't go anywhere yet. I will dismiss it shortly. But don't go. Let's see. Did it crash? I bet it crashed. I bet it didn't record. It's supposed to open up so I can pause it. Hey, it didn't crash.